Hello, everyone. I'm Andrew Fonseca with Milevision. I just want to thank everyone for taking the time to sit in on our webinar today. I'm going to drop off here for a second and wait another minute or so for some last minute participants, and then we will get the show on the road. Thanks. All right, everyone. So again, thank you for attending today. I'm going to introduce myself and my two colleagues who will be co-presenting with me today. My name is Andrew Fonseca with Milevision Technologies. I've been with the company for about 5 years. I work as an account executive in the Northeast and Midwest. So I'm just really the go-to on the product side for sales support. And I'll pass it along to my colleague, Ian.
Thanks, Andrew. My name's Ian Davis. I'm the SMB account executive for the state of New York, New England, and the Midwest as well, handling cities, population of 75,000 and under. I've been with Miovision since about the beginning of the year. Now I'll pass it over to my colleague, Dana.
So thanks, Ian. My name is Dana Oros, and my role here at Milevision is that I'm a technical account manager for New York State. So my role is kind of to be a technical support resource, not only for our partners, but also for you guys, both during the install process, but also continuing on after that, just to make sure that everything is working as it should.
Excellent. So you'll hear more from Ian and Dana a little bit later. I will get the presentation going. I will cover the presentation itself today. Dana will be providing a live demo of our platform, and then Ian will be fielding questions for the Q&A at the end. A couple of items before we get going here. As far as any questions throughout the presentation, please feel free to type them in the chat box. Ian will be fielding them throughout the presentation, and at the very end, we'll have a Q&A session. So as questions pop up in your head, please feel free to type them in the chat box. The second piece is, in the original invite link that we sent out to everybody, there's an option to book a follow-up meeting with either myself or Ian. So any cities or engineering firms or anyone on the line that would like to do a lunch and learn and get a little more in depth on the platform or the product, we'd be happy to do that as well. Today's presentation is going to be primarily focused on an overview. We are planning on doing a second presentation around the data we can generate, so we won't get too deep into that today. So the reason why we wanted to launch this webinar is we have just recently been approved by New York State DOT. We're now on their APL. So what that means is the DOT can purchase us. It makes it very easy for other cities, local municipalities to procure equipment. And more importantly, just peace of mind that it was vetted through such a credible agency as New York State DOT. So they evaluated our system in the field for quite some time for both detection, which is powered by our AI, as well as they took a quick look at our ATS PMs and some of our count data, just to make sure that all that stuff lined up. And here we are today, we're approved, so we were just trying to get the word out. A little bit about Milevision. I'm sure some folks on the line here that I know from previous years at Milevision know who we are, but for those who don't, we're located in Kitchener, Ontario. We have another office in Cologne, Germany. We've been around for about 10 years. We have over 200 employees, and most recently we went after a capital raise of about $110 million. So that we've always been a forward-thinking, innovative company. very software focused, as you can see here, with such a large number of software and hardware engineers. Now this capital raise will allow us to move quicker, innovate faster for our customers and partners. Before I get into the product that we're going to cover today, which is our video detection, a little bit about Miovision's product previously. So we still sell this product, the Scout, used by the largest data collectors in North America, as well as engineering firms, DOTs, and essentially it mounts at a traffic signal, records traffic, they send us that video, we convert that into turning movement counts, which then goes into synchro modeling for signal retiming. And the reason why this is so important is it's allowed us to collect over 7 billion vehicles and close to 1 billion cyclists and pedestrians. So we've essentially taken all of this data and taught, using machine learning and AI, we've taught an algorithm that allows our detection system to actually detect vehicles, pedestrians, and cyclists in real time, which I'll get into shortly. So before I get into anything on the hardware side, I think it's very important to understand Milevision's thinking when building our product. So there's kind of 3 pillars we look at when we built this product. A was the ability to have open architecture. So essentially, there's a lot of things around vendor lock-in and compatibility issues with certain manufacturers. Milevision looked at it as we want to be able to integrate with everything a city has today and down the road. And that can be controllers, that can be cabinets, that could be existing detection, that could be cameras, whatever that is. We want to make it very simple to integrate with what's in the field today. We also want to be able to integrate with software. So what that means is we want to be able to pull our data into any existing central management systems cities use, or other data aggregators like an MS2 or anything of that sort. So very simple open architecture is one of the biggest pieces for us when building this product. The second piece is around the ecosystem approach. A lot of data that's generated at the traffic cabinet and controller is siloed off. It's very hard to share that data with, whether it's consultants as partners or academia to innovate off of, or even just internally across adjacent departments. A lot of times it makes it hard to do that. We've built this in a way that we can essentially open up that data to whoever the city or the owner of the data, which would be the city or DOT, would want. So what that allows us to do is if an engineering firm is doing a safety project or a signal retiming project, it's very simple for cities to provide them all the turning movement count data, travel time data, some sort of pedestrian compliance data. Or on the flip side, we've also had schools innovate on top of our data. So whether it's building an app for the visually impaired across the street, or it's just to train students on using real-time data, we want to make it very easy and create that ecosystem that fosters innovation. The last pillar, we call it the smartphone model. Our CEO uses this analogy, and if I've presented to anyone else on the line in the past, you've probably heard it before. But essentially, if you look past 20 years ago, people would buy a calculator, a stopwatch, a portable DVD player, a flashlight, and then the smartphone came out. And essentially, it's one piece of hardware enabled by software, allows it to do many different things. We've built our hardware the same way. It's one piece of hardware that can be used for one thing, such as just detection today. But as a city moves and they pivot and they have new priorities and they adopt a Vision Zero initiative or whatever it may be, can that same investment do multiple things for them? And we've built our hardware in this manner as well. So when we look at our hardware, there's a hardware component and there's a software component. I've kind of broken it down into a few different, what it says here is apps, but I would say different kind of values we can provide to different folks at a city or in general. One is signal maintenance, so the ability for us to, and we'll go into this in a live demo a little bit more, so I won't spend too much time here, but the ability to provide, we provide communications to the cabinet, or we can leverage existing communications, but the ability to let cities know when a light goes into flash, a power goes out, if a backup battery kicked in, if a preemption stayed on, that type of data. We can do that real time through a web-based platform. We provide video detection, so just actuation at the intersection. and that could be for just normal actuation, that could be into an adaptive system, which I'll speak about in a second, but reliable video detection. The third piece is traffic data. So the ability to pull 24/7 turning movement counts with classifications, as well as pedestrian and bike counts at the intersection. So this is a large sample of data that we're collecting ongoing, which we'll show an example of. Automated traffic signal performance measures, pretty big buzzword over the last few years, but essentially our system can generate data that allows for agencies to look at traffic signal timing more as an active arterial management. So having ongoing data that they can make small tweaks and monitor the impact of those changes. And then the last one is travel time. There's a traffic probe built into our device, which essentially can capture travel time wherever we're installed along a corridor. Another big important piece when we talk about open architecture is third-party integration. So whether it's central management integration, we've done adaptive before. SureTrack Adaptive is one of the ones we've done, but we have also done others in the past. Blinksy, microtraffic for conflict analysis, as well as BRIS. So those are some of the third parties that we've integrated with, and we've kind of shared our data to help cities. And then we also have a department called Milevision Labs. Essentially, that's kind of like the forward-thinking department where for features that are maybe not on our roadmap just yet, but we're trying to understand the value of them. And we partner with a lot of cities who are also forward-thinking to kind of take a stab at some of these things. And active safety measures is one that we're already actively launching. We have a couple right now, but intersection health, emissions and air quality quantification, which is, if you can do it before and after to look at travel time or reduction in occupancy or split failures, can we convert that into a quantifiable data set that helps cities get budget, for example, or grant money, which, emissions and air quality, maybe that would be a good data set to go after CMAQ funding with, for example. So a couple of our partners, Amazon Web Services, we use them. They are our cloud provider, so all of our data is stored on the Amazon Web Cloud. NVIDIA is who we use for our graphic processing unit. As I mentioned, we use AI in our detection, which is quite different than video detection in the past. So those graphic processing units are used in, high processing gaming systems, etc. That's what our AIs run on. Verizon's our telecom provider in the US, and TELUS is our telecom provider in Canada. So essentially, we can provide 4G LTE communications at the intersection, but if not, we can switch that off and leverage any existing infrastructure, communication infrastructure that cities have. So across North America, we have about 3,500 plus intersections installed with a combination of either our full detection system or our communications and remote monitoring product, which is a part of the full detection system. Across New York State right now, we probably have 70 plus systems roughly. Some of them are still to be installed, but will be very shortly. And some of the customers that we are installed with, we're in the city of Buffalo, Onondaga, Albany. You can see the list here. We just threw a handful of them, but we're installed in a few others as well. So the hardware. So this is the first kind of snapshot of our hardware. There's 3 devices that comprise our video detection system. I'll start off with the device on the far left, the SmartLink. This device can be used on its own for remote access to the cabinet as well as communications. So you can notice there's some Ethernet ports, some serial ports. Essentially, you can look at this as a communication hub for the cabinet. We can plug in controllers, cabinets, conflict monitors, backup batteries, anything into this device, and it could provide communications to take all that data back into either our platform or into an existing central management system. This device also has a managed switch. You can plug in existing, fiber into it or whatever that may be. On the bottom, you'll notice an antenna there. That antenna goes into the top of the cabinet. I'll talk about it a little bit later, but our traffic probe is built into that. So the travel time that I discussed using Wi-Fi MAC address is done through that antenna right there. The device, I'm going to just skip to the camera. The Miovision 360, essentially that on its own is just a camera. It's a single point camera. It can be used for remote monitoring. You can tap into the intersection using laptop, cell phone, anywhere we have internet, and view the intersection in real time, as well as the detector zones in real time. It's the device in the middle, the SmartSense, that provides all of the analytics. So the brains of our detection system is in this device, and that's what allows us to do roadside video analysis, the turning movement counts, any of the pedestrian safety or vehicle safety data we'll talk about today, as well as our detection. All of this kind of comes up into our Traffic Link portal, which is our web-based platform, which Dana will provide a demo of shortly. So quickly on the install, I have a couple pictures on the next slide of some local installs, but essentially both of these devices go into the cabinet. We're pretty flexible as far as how we can plug them in. The next slide, I think it's in an ATC cabinet. This is an ANEMA. We've done 2070s. So it's pretty flexible from that perspective. We drill a hole in the top, or the city drills a hole in the top of the cabinet where we run the antenna down and plug the antenna into our devices. That install itself takes about 20 minutes at the most at the intersection. The next piece is actually deploying the camera up on the mast arm or signal pole. But from an installation perspective, it's very turnkey. As far as radiuses go, as you can see here, there's a quick kind of intersection assessment. Dana and our technical account team look at every intersection and provide recommended deployment locations based on the geometry of the intersection. As you can see here, depending on how high we go, you can kind of see further, but I think a good range is anywhere between 150 to 200 feet. We can see, obviously, the higher you go, the further you see. We like to be around that 30-foot mark. However, we've done them lower than 30 feet as well. It's also important to note that 2 cameras can run off 1 processor. So on abnormally large intersections where you can't see the entire intersection, include like to the back of the stop bar, as well as all the crosswalks, you can easily add another camera to kind of view the entire intersection. So here's a couple snapshots of the camera. I believe this one here is in, I want to say it's in Buffalo, but I could be wrong. I'm sure some of the folks on the phone recognize the intersection a little more than me. This one here is up quite a ways. I think it's about, I want to say it's about 38 feet. Our partner, I should have mentioned this in the beginning, our partner in the state is Northeast Signal. So Steve Atkins at Northeast Signal is the exclusive Miovision distributor, and he helps customers get this stuff deployed. So he put that camera up, and on the left here, there's another example of us in a tighter ATC cabinet, I believe, where we're sideways on top of the controller. So just some visuals on on a tighter cabinet, how could we fit? We haven't met a cabinet we can't fit into yet. So this is where I'm going to spend a little time talking about how we do detection. So as I mentioned before, Milevision has counted 7 billion vehicles, almost 1 billion cyclists and pedestrians. So we've built our detection product a little bit different than in the past, and I'm sure many on the phone know that, or on the call today know that video detection has not had the best reputation in New York State. I remember when I was when we first launched this product about 5 years ago, I remember going out into the field and just, it wasn't even a conversation starter. It was just, it was not a thing. And I think understanding that video detection had its issues. However, technology's come such a long way since then. And obviously, so has the performance of video detection. We've used all of that data that we've captured in an AI algorithm to actually model what vehicles look like, including cars, buses, trucks, articulated trucks, pedestrians, cyclists. So instead of using a background subtraction, we actually look for the characteristics of a vehicle, and as you can see, a square box goes around them as they follow through the intersection, and we track it through the movement. This allows us to address some of the conditions that you can see here, like snow, like glare, like rain, a little bit different than in the past. And not saying that our detection is perfect, but what I am saying is that we've built a platform that is agile enough that we can actually improve quite a bit over time, and out of the box will be extremely more accurate than maybe some video detection of the past. Another big piece is because we use AI and machine learning, we can also provide continuous counts. So you can see here, this is a busy intersection. I believe this is in Toronto, where they're actually using us for permanent count stations. They're just using us for counting purposes. We're able to collect that data 24/7. We're also to count by lane in a true multimodal count. Because we're tied into the controller, and because our detection system is able to track vehicles and pedestrians, we can also look at red light running. We just released pedestrian compliance, and when I say red light running, please don't be confused. We're not giving tickets out, but more to understand where it's happening, why it's happening, not to victimize pedestrians or vehicles, but more so to understand why it's happening. ATS-PMs, which I mentioned, using stop bar detection and upstream detection, we can do an array of automated traffic signal performance measures. And then also video management, you can tap in at real time, you can view the intersection. We can actually pull our RTSP feed into any existing video system. So if in the city of Detroit, they're using a Genetec system, or actually in the town of Amherst, they're using an Exactvision system. We can take our video stream and we can actually pull it into those existing platforms. When I talked about improving over time, I think it's important to understand how we do this. So our cameras installed at the intersection. We take our data up to the cloud. We can then take that data, bring it back to back through our algorithm, and we can continuously teach it to get better. We validate that and make sure that it works, and we push that out to all of our customers over the air. So no one's ever at the intersection with a USB. We update everything remotely. But I guess to tie this into a story, say there is a horrible snowstorm in Vermont, and we're having issues actuating a movement for whatever reason that is. We're able to take that video and then take other video that we've collected in the past in snowy conditions, and we can tweak and retrain our algorithm and push that out to all of our customers. So that's an important to know, that we get better over time, and there's not a cost associated to that. That's just how Miovision kind of manages its platform. So on that note, I'm going to pass it over to Dana, and we'll jump in and do an actual live demo of our platform.
All right, perfect. Thank you, Andrew. Okay, so we're going to jump right in here and basically tie back to a lot of the things that Andrew was discussing. So basically, this is our traffic link UI. This is what you see when you are going to first log into the platform. All of the dots that you see here are intersections here in the region of Waterloo that has kindly given us permission to use them as sort of our demo site here. The first thing that I'm going to talk about is the alerts that we were talking about earlier, and being able to manage those alerts, obviously remotely, and get them remotely as well. So we can see actually a couple on the map here already as pins showing up this way. But we can also set them up so that different users can receive those either through email or through SMS. And to go about doing that, we just need to go up to our little user here at the top and go to Manage Users. So here we can see all of the different users up here at the region of Waterloo that have access to the platform, and then you can see the different alert types that they are receiving. So I'm going to pick on Dave here. I'm going to go into Edit, and we can see a little bit more detail. So first, we do have obviously different user permissions built into the platform. And there's 4 different ones that you can do. When you're first setting it up, you're going to need an administrator. But after that, you can add people as read-write, view only with video, which is very handy if you are working with a contractor. You can give them view only. That way they can't make any changes, but they can make sure that things are working correctly, as well as view only. So again, you can come in, see the information, see the reports, but you're not able to make any changes. The big difference between read and write and administrator is going to be administrators can obviously add and remove users, whereas read-write cannot. So you can really control exactly who has access to what and what parts of the platform as well. In terms of the alerts that you can get, we have them listed over here. So we have things like flashing lights and power loss, which is great because you don't have to worry about having somebody call in when that happens. You'll receive, again, either an email or an SMS, depending on how you have it set up. And you'll know before even most of your users. We also have the detector threshold exceeded and the preempt threshold exceeded. So if you do have preempts set up for emergency services, if that gets stuck on for whatever reason, you'll get an alert on that. So there could be a number of reasons why that preempt is stuck on. Obviously, there could even be an accident or something like that that you can look into. Detector threshold, if a detector gets stuck on, again, you'll know about it through email or SMS. And at the bottom here, you can also see things like UPS battery low or battery in use if you do have a UPS battery hooked up to our system. And then you can choose your notification method, either email, SMS, and then you can choose to also batch those alert notifications if you don't want to be getting them all at every time they kind of pop up. That being said, you can also schedule these alerts. So if you are obviously on different shifts, on different days, you can set up multiple different schedules. So if you're working Monday to Friday, 9 to 5, and that's the only time you want to receive those alerts, you can set it up like that. That being said, you could add a extra schedule here for, say, Saturday and Sunday, between 7 to 3, or maybe you're working the night shift, and you can set that up for each different person independently. So you have that kind of flexibility. So that is the user management section. I'm just going to pop back over to our map. And the actual UI here, the menu is along the side. You can see all of our different icons here along the side, and we're just going to kind of go through each of those. So for the intersection menu, we're just going to click on the intersection we want to take a look at. I'm going to take a look at Herb Street and Caroline here just because it is a rather interesting intersection with multi-use cases going on. And the first icon we have is telemetry here, which gives us our telemetry page. So we can see exactly what's going on at the intersection right now, what telemetry we're currently pulling from the controller. So we do see our traffic signals right here, our pedestrian signals. We do have a couple preamps set up here too for our light rail as well as emergency services. And then at the bottom, we actually have our detectors. So you can see those detectors lighting up as vehicles enter the intersection. And you can see it actually on our overhead map here too. So the approach view is going to give you kind of an idea of what people are seeing as they're approaching and entering the intersection. And then we also have our timing diagram here as well, which is showing us exactly what's going on inside of the controller. So is it behaving the way that you're expecting it to? You can actually see the different phases as they pass and what's going on there. And you can go back in time with the timing diagram here. So if you do want to see what was happening at, say, 9 a.m., you are able to go back to that. Or if you need to go back in time to a different day of the week, you're able to do that too. So that's the telemetry view. And I'm just gonna go back to our intersection view here. The summary view here on the side just kind of gives you an idea of what's going on at this intersection, a quick overview. So you have any active alerts that are currently open, which is there's none, so that's good. But also all the devices that are installed here as well. So you can see all the controller, our smart link, and our two. This is actually a dual camera install, so you can see our two cameras here. But moving down below telemetry is the exciting part, the video section here. So again, we have two cameras, so we're going to have two camera views. And I apologize, I'm on my Wi-Fi at home, so we'll see how this goes here. So the first thing we have is the live view. So we can see exactly what's going on at the intersection live right now. And as you can see, this is one of the reasons why I like this intersection is we have our rail going through the middle of this intersection. We have a lot of pedestrian traffic going through here. So it really highlights the things that we can do in a multimodal sense, which we're going to see if we move to the detection overlay, which is our multi-view here. Just going to expand that. And 1 second, I might need to give it a bit of a kick. Again, my internet, I apologize. There we go, perfect. So we'll expand that. So this is what our detection view looks like. You can see our 5 different views. We usually set up one for each of our different approaches, as well as our turning movement count, which is here in the middle. So there's a lot going on here. Actually, we have a train going through right now. But you can see as cars enter the intersection, as they come up to these yellow zones, they basically turn green. That's basically saying we have detected that vehicle and we are putting in a call to the controller. That's also how we are doing our counts. Here's the turning movement count. So as these cars are going through the intersection, take a look at this screen right here in the middle, you'll be able to see those lines light up purple. Every time that happens, we are basically saying we've counted a vehicle as it's gone through that intersection. But as I mentioned, I really like this intersection because it does show we're using it in a number of different ways. We have a lot of pedestrian tracking that we're doing here. You see these pedestrians crossing here, and a line will light up there as well where we're counting the pedestrians. In particular use case here was obviously seeing how pedestrian traffic is interacting with the new train here. We actually have a zone to see if there's any pedestrians crossing near the train where they shouldn't be. So there's a bit of a safety aspect here too. So definitely a very interesting intersection where we're doing the detection, we're doing the counting, but we're also obviously looking at sort of the kind of safety stuff that we can do and counting those pedestrians. And there's a bike going through there as well. We are able to recall video for 7 days. So we do 15-minute kind of bins of video. We'll keep 7 days worth on the hard drive of the actual SmartLink. And then after that, we will overwrite it. So if you do want to recall video, see what's going on at that intersection, you can choose to do that and then hit recall. That's going to upload it into our cloud and you'll have access to it for as long as you're with Milevision. So moving down from the video section here, I'm just going to go down to devices. We will head back up to the reports in a minute, but this is basically showing us all of the different devices here, as I mentioned earlier. But one of the things that's kind of handy, and we have, again, permission to take a look at here, is the ability to remotely connect to the controller. So I can actually click on here and hit connect, and this is basically going to bring up the screen here. It basically gives you an interface that allows you to make changes to the controller remotely. So you don't need to go to the intersection. You can basically come in here and use this interface in order to make the changes that you need, which will save you a lot of time. Finally, the last bit is our insight section, which I'm going to click on here. And as Andrew mentioned earlier, there's a lot of information here. It's going to be discussed in a separate webinar, but I will highlight the turning movement count and what that looks like. So we had our turning movement count review. This is what the report looks like that comes out of that particular view here. So we can see over a 24-hour period, number of vehicles, total number of pedestrians. Oh, that's a lot of bikes. That was more than I was expecting, actually. And then the AM peak and the PM peak. Down here, we have a graph that basically shows each of the different movements and the amount of traffic that goes through at that particular time, as well as the number of pedestrians. And then we have the intersection count. And here we can get a little bit more creative. Say you want to see exactly how many buses went through at this particular time. Maybe it's a very bus heavy area. You're able to basically see exactly in 15-minute bins how many buses pass through here and where those kind of AM peaks and PM peaks are. Same thing with pedestrians. We could add pedestrians and see where the peak is there. So very much a later in the evening peak for the pedestrian crowd now. I wonder how much that is related to COVID, but you can definitely see where that is. So let's look at the TMC report. And that's a basic overview of the TrafficLink platform. I will now pass it back to Andrew. Thank you for your time today, guys.
Thank you, Dana. Okay, so as I mentioned earlier, you can get pretty deep into the ATS-PMs and some of the data we can generate there. We thought it would be best to do a separate session using a local example. We've done a couple of reports for some other local towns, so we will likely do a follow-up webinar, and it'll be focused specifically on the data and how both cities and engineering firms are using this data to address traffic congestion, safety, etc. So please stay tuned for that. Kind of going back into the last slide about improving over time, I think it's important to show a case study or an example of when we've done that. And sometimes, it's not always a perfect scenario. It's not always you come out of the gate and you're working amazing. But I think a lot of times those situations show character and show how vendors and our partners support our customers. And this is a great story. Portland, Maine had a dual camera intersection, which was, it caused them a lot of issues. It was a massive intersection, as you can see in the overhead here. They tried many different detection types. They tried everything from video to radar to loops, and it wasn't working the way they wanted it to. So it was in our early conversations with Maine, we said, put us at your hardest intersection, and that they did. So they installed us here. If anyone's familiar with Turl, speaking about APL, Turl is the Traffic Engineering Research Laboratory, which is the department in Florida that does their APL. It's a very rigorous APL process. It took us a couple of years to get on there, and one of the mandates that they have is you need to be 98% or higher in actuation accuracy in order to get approved, but this is in their lab. So the way that Miovision took this challenge was saying, okay, if 98 in Turl's lab is a pass, let's aim to be 98% in real world conditions. As everyone on this line knows, the weather in the Northeast is very different. It's not bluebird skies. Weather conditions are extremely important to make sure that we can adapt. So 98% in the sun doesn't really help. 98 doesn't help in the rain or in the snow. So we installed in their intersection, and are originally out the gate, we were at about 97.3% accuracy. So they weren't extremely happy about that. They expected more, but this is where we can work and we can improve over time. So after a few different upgrades to our models, so taking some data, tweaking, and pushing it out to not just Portland, but to all of our customers, we were able to get up to a 1.7 error rate. So essentially, we were able to get to a 98.3 real world accuracy in this deployment after working with the customer over a period of a couple of months. So this is important because not every intersection is the same, and not every deployment is the same. So if we start looking at even adaptive projects or anything like that, we can do a lot of interesting tweaking to make sure our accuracy is where it needs to be. One thing we might have mentioned is the ability for us to tweak timing plans remotely as well. So you can actually extend, tweak, we can do quite a bit of different things remotely on the fly. So from a laptop, you can actually tap into the intersection and make changes if you'd like to, which provides, especially the technical and the maintenance folks in the field, a lot of flexibility. This is a snapshot of that intersection in real time. You can see it's a lot of vehicles, a lot of action, but at the end of the day, I'm not going to read this word for word, but we received a nice kind of note from Jeremiah Bartlett, who is the transportation systems engineers of Portland, Maine, and kind of talked about the trouble they've had at the intersection previously, and more importantly, how we work together in achieving the goal that they were trying to get. So we're doing good for time. We're a little bit ahead. So if at this point, if anyone does have questions, I'm sure Ian has been fielding questions that have been coming in direct to him versus anything that was just kind of thrown up to the group. But I will pass it over to Ian to go through the Q&A.
And Ian will come off mute. Thank you very much, Andrew. Yes, we have had some questions come in. Thank you very much. And please feel free, if you haven't asked a question that comes to mind, please feel free to type it in the chat screen, and I'll get to it. What a surprise, dealing with the state of New York, and the first question has to do with weather. Being from your neighbor Ontario, we completely understand. So the question is, have you experienced any camera housing cracks or defects from a New York winter and summer weather conditions? And the answer is no. Obviously, being a similar climate up here, we run into extreme wet winter and summer conditions as well. No cracks or physical damage have been reported to this point in time. Our hardware is built for real world conditions, and it takes a Canadian winter into mind, which I like to think also includes a winter in upstate New York as well. So thank you for that question. This one Andrew already dealt with. Can you run two cameras from one device? And as Andrew said, the answer is yes. Our typical deployment at a 4-lane intersection, we like to get our camera about 30 feet in the air, and at that height, the fisheye lens can view in a range of 150 to 180 feet in diameter. In extraordinarily large intersections like the one you saw in Portland, we put two cameras in kitty corner to each other. One question you might want to ask is, would you require a second SmartSense processor with a second camera? And the answer is no. Two cameras can be processed by the one SmartSense processor. Oh, and I see another question here. Do you need SmartLink if you have existing communications at the intersection? Also, is travel time measured just through the intersection? Okay. If you have existing comms, then you can use them. What we've done in many cases where perhaps a municipality would have existing comms at 50% of their intersections, well, you can quickly deploy SmartLink at the remaining 50%. Excuse me for 1 minute. And what that, and it's very easy deployment. Being cellular, there is no disruption in digging up sidewalks or pavement to lay fiber or copper to that intersection. And as far as travel time being measured just at the intersection, no, it can be measured along an entire corridor. So as Andrew mentioned, we're using the Wi-Fi MAC address in cell phones, and our systems are tracking the cell phone as it moves along an entire corridor at different times of day. It will give you corridor timing reports. Now, a good question there is, what if I'm driving through that corridor and I decide to pull over at a restaurant and have lunch? Obviously, we flag that as an anomaly and take it out of our final report. If it's an hour to get through that corridor and everyone else is taking 5 minutes, we think they've stopped to have lunch. We have a related question here as well. Can you use Miovision equipment on existing fiber systems, or do you have to use your cellular deployment? And the answer, you can use your existing fiber deployments, no problem at all. The fact that we use cellular technology is so that we can address the intersections where you haven't already deployed a fiber or copper network to those intersections, and can be deployed very, very easily. Looking at another question that's just come in here. Can you be installed in TS1, TS2, and ATC cabinets? And the answer to that is today, yes, for TS1 and TS2 cabinets. ATC cabinets are definitely on our roadmap, and we're already testing the first ones in our facility today. So we hope to we will be able to deploy in ATC cabinets this year. Oh, I think Dana touched on this one. Do all users have full administrative privileges, or are there levels of access when going into the system? And there are levels of access. You would designate into the TrafficLink web portal, you would designate a system administrator. Then you can have people who can have read-only access to the reports, and you can also have people who can have read and write access to the reports. The administrator, their additional benefit would be that they can make more changes, and they can add and delete users to the system. So I believe at this point in time that's all the questions we had. Please, I want to draw your attention once again to the chat bar. We have set up an opportunity for you to book time right now with myself, Andrew, and Dana, so that we can do deeper dives for you into the system. And we welcome the opportunity. So please take advantage of that, or at least copy that link so that you can book some time with us later on. Thank you very much. I'm going to pass it back to Andrew to wrap us up now.
Great, thanks, Ian. Appreciate that. So once again, we're finishing early, which is great. You have some time back. Sun is shining here. My dog didn't bark throughout the presentation. All in all, it's a good day. As Ian mentioned, please feel free to book some time with us. We're more than happy to do a more of like a lunch and learn deep dive with you and your teams. And obviously, if there's any other questions in regards to pricing or anything on that front, please connect with Northeast Signal. Steve's doing an amazing job, not only educating our customers, but kind of handling all of that as well. So I will leave it at that. Again, thank you everybody for the time. We look forward to working with all of you in the future. Bye-bye.